Get him!
March 1st, go back. Tomorrow, Monday, 1 o'clock. Lot 1 through 3. Fire, 8:15, 9:15, 10:25 to 11:25. Lunch, 11:24. Lunch normal time. Lot 4 is morning time tomorrow after lunch. So, people part-time. You show up, the rest of you are free to go after lunch. Would like book club meets tomorrow during lunch in the library. Selling in the current math class. Want to test your skill against other students around
Quiet!
writing rights? That is true. There'll be a meeting for any student interested in participating in the West River Math Contest. Wednesday over Wednesday, Mr. Spears. That very well in that class.
They have not had the math contest in 2 years.
Mr. Spear
Spearfish was 6-time reigning champion for it. We are recruiting. If y'all want to do it, it says, look at me, I'm the champion, I'm smart. You put it on applications for scholarships and stuff.
Log on to Zoom, open your graduation speaker. Voting will open again tomorrow morning. Closed at the end of the school day on March.
I forgot. Talk to Spear. I just know that we haven't done the math competition in 2 years. So now that it's back on, we are recruiting at all levels. And we need our smarty pants kids to go do math.
I'll try. Music Matters dinner and concert Tuesday, March 15th, 5:30 to 7 before the Pops concert. An online auction raffle items that evening as well, and a nacho bar. All fixings $5 per person, or $20 for the family. Come enjoy a night of musical entertainment and food plus supporting the arts. Any of your art shows sponsored by the Christmas Masters Opera House. All students are encouraged to attend and enter the high school division. See Mrs. Howard and Mrs. Folks for more information. Interested in joining the tennis team this spring? Sign up in the activities office. Coach Kohler will have more information. Before first practice on March 14th. Athletic Booster Cup scholarships. 2 for boys, 2 for girls. $1,500. Fill them out. Seniors, check the scholarship listing on the guidance website for all available scholarships. I congratulate the March Senior Students of the Month, Aubrey Redinger, Leaf Sandness, and Ashlyn Burbrick. All please stand for the pledge.
Got everyone today. Full house. Yeah.
All have a drink. Oh.
Phone's still going. Okay. And give you a minute, and then that's getting a little excessive. Okay. Looks like most of us are there. We're just finishing up the very last train of it. So I'm going to start it. When we say two different ways, the two different ways that we talked about are long and synthetic. So most of us caught the 0 as a placeholder thing, or there was a whole lot of eraser shavings next to your paper. So you caught it eventually. I take x to the 4th divided by x, distribute. Change my signs because I subtract. Drop it, a little warm. Start over. Negative 3x to the 3rd divided by x is negative 3x squared. Go again. Distribute. Negative 9x squared. Change your signs. Change, change. Getting 7x squared. 0x. Divide again. Getting 7x. 7x by the stuff is 7x squared plus 3x. 21x. That was close. Change your signs. Getting negative 21x. Huh. All out of pities. Different color. cubed. Negative 21x divided by x, negative 21. Negative 21 times stuff, negative 21x. Negative 63. Change your signs. Getting 60. So I don't just say R60. We put on there plus 60 over x plus 3. So if I get one answer that way, then when I do synthetic, I should get the exact same answer. I go by negative 3. Drop the first term, again, a little hot. Say negative 3 by 1 is negative 3, add them. Negative 3 by negative 3 is 9, add them. Negative 3 by 7 is negative 21, add them. Negative 3 by negative 21 is 63, add them. And I get the exact same thing. So I'll just kind of point it over there. Okay? So, A, did you actually do the process for long division? Okay? Even if stuff ended up messed up, you did the process for long division and synthetic division. B, we got all the little moving parts right. Did our arithmetic correctly, our negatives, all of that's good. C, you got, where am I going to have it? The zeros as a placeholder. Okay? If you did not have the zeros as a placeholder, this whole thing is just screwed up beyond belief. Okay? Now, if you didn't have the zeros as a placeholder, that does monkey with your answer. It monkeys with your remainder. But do you still have everything shown? It's just really wrong. And then I'm also going to say you have this with the correct remainder written as a rational expression instead of just R60 or something like that. Okay, so 0 as a placeholder, setup, work. Final answer. Anything about it? Cool. I was only asked one question last night. Do you have any for me now? 53. Oh, back up. All right, find the value of k. Okay, that was the one that was asked. So what you do is you work backwards. I know that if I have 1, negative k, 2, and negative 4, and I do synthetic division with 2, I should get a remainder of 0. Okay? So I kind of work my way in at it from both sides. If I come at it from this side, what has to be here? Positive 4. So I know that 2 times something makes 4. Well, if that's a 2 and I added something, that's got to be a 0. I have a 0 here. That means 2 times something was 0. I have negative k here. Something had to be here to get rid of it. Positive k. And there's a 1 here. I know 2 times 1 is k. 2 times 1 is k, so k is 2. Ta-da! Okay, I can also come at it from the other side. Say, I know that 1 drops here. 2 times 1 is 2. Then I could write this as 2 minus k. 2 times this is 4 minus 2k. And this is how the directions did it. And then combine those, and then at the end you would set it equal to 0. So I can either come at it from this direction and I turn it into an equation, or I can come at it from that direction and just divide by this, divide by this, divide by this. So, either way. And that's why I like these problems as a way of reinforcing what synthetic division is doing, is because you can come at it from multiple angles. That was the only one that I was asked last night. Anything else? Are we still good on time? Like, I mean, I'm trying to cut it from that like 6, 7 range down to 5, like bare bones, one of those, one of those, one of those, one of those done. Do you feel like you're getting enough practice though? Like when it comes time for test day, do you feel fluent enough with it? Maybe we're just freaked out about I need to make sure that everything's perfect. Okay. All right. Then we almost finished yesterday. There was only one example left. No. Because it has to be 2. If I come at it from both directions, if this is 0, I had to add 4 to it to make 0. This number comes from 2 times something. Oh. Yeah. I suppose when there's 2's everywhere, we probably need to clarify what 2 means, right? Okay. So we did a remainder theorem. Remainder theorem is synthetic substitution. I can do synthetic division to evaluate for a known variable value, and yay, awesome. The other part of 2.3 was the factor theorem. And this we already knew by definition. Said if x minus c is a factor, then c is the 0. Well, then that also means f of c equals 0. So that means I can plug c in by synthetic division and I should get a 0. And all of this is leading us towards section 2425, which is solve every polynomial in existence. You did it in Algebra 2. Use the factor theorem to tell me if it's factors, and then write a factored form of the thing. So, if I want to know if x minus 1 is a factor, then I'll just do synthetic division. 421, 25, negative 5, 3. And I will try 1. So if x minus 1 is a factor, this better come out as 0 at the end. In fact, I'll put my little, there again. 1 by 4 is 4. Add them together, 25. 1 by 25 is 25. Add them together, I get 50. This is going the wrong direction. 1 by 50 is 50. Add them together, I get 45. 1 by 45 is 45. Add them together, I get 48. Sad face. Okay. If that was a factor, I should have had 0 as a remainder. It didn't, so it's not a factor. So it says, determine whether they're factors or not. I'm just going to say no. And then, I'm going to do it again. I'm going to say 4, 21, 25, negative 5, 3. Womp, womp, womp. Except this time I'm going to try -3. Multiply, add. Multiply, add. Multiply, add. Multiply, add. All right. So I did all the stuff and I got 0 as a remainder. That means it is a factor of. Now the other part of the direction says to write a factored form. We've run into this a couple of times in the last few sections. The wording in your directions matters. What's the difference between a factored form versus the factored form?
There's multiple ways for a factor.
As long as there are factors, you're done. So in this case, I can just write it as x plus 3 times, where does this degree start? Cubed, right? I took a 4th degree polynomial and reduced it by 1. So I have 4x cubed plus 9x squared minus 2x plus 1. That's a factored form. When they say the factored form, it means factor completely. It should be down to just linear factors and constants. It didn't ask for that, so don't worry about it. Orange is fine. But if it says find the factored form, you'd have to keep going with that cubic. Okay? You'd have to find more. For contestant 2, and this kind of leads us into the next section. If I have 2, -1, -41, -20, if I remember right from previous years, I try -4. I multiply, add. Multiply, add. Multiply, add. Okay, it works. What's that? 5, 2, 1, 10, 1/2, -1/2. Riddle me this, Batman. If I say 30 divided by 2, what do I get? If 30 is 15 times 2, but 15 is 3 by 5 by 2. When I divide 30 by 2, the other factors are still there in the quotient. The other factors of 30 are still left inside whatever remained after I divided. So I don't have to make another bracket. I don't have to make another synthetic division bracket. Do you remember this from Algebra 2? You just keep going. Right? You just keep going. If -4 was a 0, if x plus 4 was a factor, and then I get rid of it, to check if this is a factor, it should be in whatever's left. So, I'll just keep going. I'll try 5, 2, 10, 1, 5, 0, yay. Okay. Now that works both directions. If I had started with 5, and then it would have worked, and then do 4, or -4, it would have worked. Because multiplication is commutative. The order I multiply in doesn't matter. If I say 5 times -4, or -4 times 5, whatever, I'm going to get to the same result. And that's leading us into 2-4, where I can just synthetic divide a chain of these things until I get down to the quadratic that I have to throw in quadratic formula. Okay? So both of them were factors. I suppose I should have written that for the other guy. Yes, yes, and yes. Okay, now it says to write a factored form. Now that I know two of the factors, I can write x plus 4, x minus 5, and what's left? There you go. Right, because I took a cubic and I reduced it down 1, 2 degrees. So it should start at x to the first.
So if it wanted the factored form, would we have to include the 2x squared minus times 5?
No. The factored form, this happens to be the factored form because it's in linear factors. It's both. It's a finger and a thumb.
So if you do it like you just did, like where you do the double thing,
Whatever's at the end, yep. So, tell me if they're a factor. You do it by synthetic division. If it works, you don't have to start over. You just keep going. Let's just do 6b. I think we're fine with that. B. B. So you're just seeing, is it a factor or not? If it's not, rewrite, start over. If it is, keep going to test the next one. All right. So I try the first one. Multiply, add. Multiply, add. Multiply. Yay. So because that one worked, because I know that that one's a factor, I don't have to start over. I can just keep going to test 3. Multiply, add, multiply, add. Yay. So because I've shown that yes and yes, they're both factors, my factored form of is x minus 6, x minus 3. What's left over? Yes and no. This is a factored form. But if I were to just take the 2 out, that's it. The only difference. Now it's the factored form. Okay? Orange is all you need. If you go to white, yay. Okay? That was it. That was the only thing from 2.3 that we missed yesterday. So we were really, really, really close to being done. All right. So the reason we do all of that is because section 2.4 is kind of the creme de la creme of Algebra 2. Y'all remember chapter 5 was kind of the heart and soul of Algebra 2, probably the toughest section, where it was, now that you have all of these different properties and rules and stuff like that, I want you to solve any polynomial I give you. You might have radical answers, you might have imaginary answers, you might have rational answers. I don't care what it is. Here's a degree 5, find them all. To do that, a bunch of famous dead dudes come up with some various theorems, okay? See, in the ancient times, before the advent of the graphing calculator, if you wanted to know what the zeros of a thing were, you'd do synthetic division, yeah, and if you get 0, yay, it's a factor. Good. But how do you know what numbers to choose? There's an infinite number of numbers to choose. Do I just pick one and go? What happens when the zeros were negative 7/3, positive 21/3, or 22/3, and 2 imaginary numbers? When were you going to guess those? Right? So we've got all these theorems to help us narrow down what the possibilities are. First one, rational zero theorem. Maybe you remember from Algebra 2 saying, mind your P's and Q's. It's, if I write all of this out, remember that's our polynomial, they're effectively saying that I'm going to have Q, x to the n, stuff, plus P, meaning my leading coefficient and my constant at the end. If my polynomial has any rational zeros, can be written as a fraction. So that's nice stuff like -2. That's decent stuff like positive 2/3. That's trash stuff like -17/15. Any of those that are possible zeros, they come from taking all the factors of this over all the factors of that. And you probably remember doing plus or minus all this stuff over plus or minus all this stuff, and then you'd write out the big list. Now, the list, what happens when it's 16, 25, 24, different numbers to choose? Guessing and checking from 24 numbers is still better than guessing and checking from 24 billion numbers. Okay? So this just helps me narrow it down. I don't want to guess and check 1,000 numbers. I just want to guess and check a handful of numbers. So list all the possible rational zeros. The possible rational zeros. Okay. Y'all remember our symbols for the different sets? Natural numbers, whole numbers, integers, rationals, irrationals, reals, complex. Okay, it's kind of a blurry double Q. The rational zeros are all of the factors of my constant term, so plus or minus 1, over all the factors of my leading coefficient. Guess we got to start somewhere, right? Baby steps. Now, I can't just leave it as a fraction. I want to actually write what they are. So, if it's a positive 1 over positive 1, a negative 1 over negative 1, a positive 1 over negative 1, or a negative 1 over positive 1, what are the only two possibilities? Plus or minus 1. Okay? Now, it says determine which, if any, of them are zeros. How do I know if it's a zero? Synthetic division. Okay, we're going to get real fast with it. 1, 0, 2, 1, Don't forget your 0 as a placeholder. And I'm going to try 1. See if it works. 1, 1, 1, 1, 3, 3, 4. Nope. I tried 1, it didn't work. So I try again. Except this time I'll try -1. -1, -1, 1, 3, -3, -2. Huh. Neither of them worked. So what are my rational zeros? There aren't any. Now it's going to have at least one real 0. But this is my possible rational zeros. And then after that I will say there are no rational zeros. The only real 0 for this one is a cube root of thing. And then it's got 2 imaginaries. So, kind of gross. That's okay, I don't have to find them. It's just asking about the rationals. Same thing here. I start with my possible rational zeros is going to be all the factors of 9. So it could have been ±1, ±3, ±9. Y'all get that it's just going to be plus or minus no matter what. Okay. Over all the factors of my leading coefficient, ±1. So when I write it out, it's not very complicated. It's just plus or minus. I like throwing my plus or minus out front of the set bracket so I don't have to keep writing it. 1, 3, and 9. Right? Instead of writing plus or minus, 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 I'm just going to throw it out front. So I've got 6 numbers to try here. I don't want to try 6 numbers. Instead, I want the front table to try 1, the middle table to try -1, the middle table to try 3. Want y'all off to the side to go -3. I want you at the back to go 9. I want you at the back to go -9. Go! Ooh. Don't get caught in the trap. I almost did. Remember your 0 as a placeholder. Okay, so front table, 1. Does it work? No? -1. Does it work? Cool. Three, does it work? -3, does it work? Nine, does it work? -9, does it work? Because what is this? As a polynomial, I just reduced it down 2 degrees. X squared minus 3. If I set that equal to 0, My two remaining zeros are plus or minus square root of 3. Square root of 3 is not a rational number. So these are my possible rational zeros. My actual rational zeros, so I'll say x sub rational, is -1 and -3. Okay? Those are specifically the rational zeros. There's two more. There's irrational zeros. But this would be more like end of the semester. My grade in this one class is looking a little sketchy. I should only hang out with my rational friends for the next 2 weeks. Because, oops. Okay. So, that's it. It's the rational root theorem. I don't see a need to beat it to death. Let's do 1b. And since you're all at tables of multiple people, maybe it'd be a good idea to divvy up the work instead of guessing and checking. 1, 2, 3, 4, 6, 10, 15, 30. Yeah, instead of guessing and checking 16 numbers. You were in here last semester. What are we about to do after this? Gaze into the crystal ball. Guess really good. Okay.
I'll get -1 and -3. Yeah, because kids with only.
You want to do 1, 2, 15, 30, and I'll do 3, 5, 6, 7.
You have your choice of what are they at?
One.
Yeah, I know. I know. I know. Nothing I didn't like it. Yeah.
God, what's taking y'all so long? Like, I guessed them right the first try. I guessed them perfectly right away. What's taking you so long?
I'm not a master.
Yo, can I tell the difference between you happen to guess -5 on your own because you just felt lucky about -5, or you looked at a screen and said, that kind of looks like a -5. I'm going to try a -5 first. Dump it into y1. Okay? Y equals. Oh, yeah, we have all this stuff in here still. Okay? Even in Algebra 2, what I tell kids is this idea of guessing and checking, really, how fair is that if you got Brooke, who's over here just like on her 9th problem, furiously scribbling, and then behind her, Callie's over there like, I was done 2 minutes ago. Like, just because you happen to choose the right numbers to guess first, can you narrow down what you're going to guess? Okay. Now this, again, this defeats the purpose. Before the graphing calculator, we had to narrow down our options, narrow down our options, narrow down our options, guess and check until it worked. Well, now I've got the rational root theorem. I'm going to plug stuff in. What is it? 1, 3, -7. Okay. I'm going to say x to the 4th plus 3x to the 3rd minus 7x squared plus 9x minus 30. Graphify, and I say, you know what? I feel really good about trying a -5. I feel lucky. Okay? And then I go and try -5, and it worked. Man, I'm good at this. What am I going to do next? I'm going to try 2. I just feel really good about 2. And I try 2, and hey, it works. Okay? There's a difference between you should know the rational root theorem because it's something that pops up on standardized tests versus you need to use the rational root theorem for every polynomial you run across. One of them is you should know this because it is valuable information. It helps us narrow things down later on in math. The other is, y'all, I'm going to be practical. Yes, I have my rational roots listed out, but I don't feel like guessing and checking 16 things. I'm just going to guess really good. Okay? So, I think you would appreciate that for the next round because you probably didn't want to do synthetic division with all of these incoming fractions. Okay, same thing, but now we have a coefficient that is not 1. So my possible rational zeros are plus or minus all the factors of 8, 1, 2, 4, and 8, over all the factors of 3, 1, and 3. Again, you can't leave it like that. You have to write them out. And I say it's plus or minus all this junk over 1. So 1 over 1, 2 over 1, 4 over 1, 8 over 1. And then all this junk over 3. 1/3, 2/3, 4/3, 8/3. So again, I've got 16 numbers to check, but half of them are fractions. I'm betting you weren't going to guess those fraction numbers. What I will do is still go over to my calculatron here. Glare. 3x to the third minus 7x squared minus 22x plus 8. And I'm going to gaze into my crystal ball. I'm going to commune with the other realm, and I'm going to say, I feel really good about 4. I feel really good about negative 2. How would I know what that is if I didn't do the rational root theorem? Is that 1/4? Is that 17/58? Right? But because of my rational root theorem, I look at that, I look at my rational list, and I say, what is that probably? Probably 1/3. So I'm going to guess really, really good. I'm going to guess negative 2, 1/3, and 4. Okay. So 3, negative 7, negative 22, 8. And I'm going to guess a negative 2. I just feel good about it. Negative 2 by 3 is negative 6. Add them together, negative 13. Negative 2 by negative 13 is 26. Add them together, I get a 4. Negative 2 by 4 is a negative 8. And oh, look at that. I guessed good. I'm also going to guess a 4. I just got a good feeling about 4. So 3 by 4 is 12. Add them together. 4 by negative 1 is negative 4. Add them together. Skadoosh. Gone. Okay. And then, what I probably wouldn't have guessed if it wasn't for my rational root theorem, I feel really lucky about 1/3. And it works. Now, I'm almost done. What did I just synthetically divide by? A fraction that has a denominator. What should I do to my result? Okay, so I also need to cut this down to 1. Because at the end, what I should have is 1 times x minus a third times x minus 4 times, right? See, leaving that 3 there, what you're effectively saying is 3 times x minus 1/3 times x minus 4 times x plus 2 as a factored form. Because we know that this was actually 3x minus 1, right? That's why that 3 is left over when I do this. So, I listed my rational roots. My actual rational zeros, turns out all 3 of them are going to be negative 2, 4, and 1/3. I still have the work to back it up. That's the key here. I want to make sure you understand that. I can't just list my rational roots, go to my calculator screen, just write things down and not have the work to back it up. I want you to have the synthetic division to back it up, because that's how we're going to get to our irrational roots later, is going in that chain. So, you, part B, get them. Class 1, you're in charge.
Fancy bracket.
Good. That way I don't mess up, because I'm gonna mess it up on you. Okay, that doesn't brown. Both. I think it's the first term. It's always one, and then if there's a different number.
Oh, wait. Yep.
No, it's negative 21.
Plus or minus. When you write out your possible rational zeros, again, just like when we were writing repeated zeros, you don't have to repeat yourself. So 1, 3, 7, and 21 over 1. And then 1/3, gotcha. 3/3, I'm not going to say it again. I already have one up there. 7/3. 21/3, I'm not going to say it again. I already have 7 up there. Okay. So I have 12 things to check. I don't want to check 12 things. So instead, 3, -18, 0, 2, -21. Instead of guessing and checking, 12 things, I'm going to commune with the force, and Baby Yoda tells me what? Feel really good about a -1. I heard this voice from the ether. It said -1. I should probably try that. Wait. 3, -3, -21, 21, Baby Yoda lied to me. Huh. Now, this is the key to it, okay? Yes, -1 looks like it hits -1, right? But it's actually a radical. It's a this plus or minus squared of that. And it comes really close to -1, which is why you can't just look at the screen and say -1 and not show your work. At back row. Okay? So, we've shown that -1 doesn't work. I had a good guess. I heard a voice from the ether. Turns out that all of that seance stuff is just crap. So, maybe I should try something else. What else should I try? 7? I hear a 7. This voice is a little more insistent. I'm seeing something wearing blue. 7 by 3 is 21. Add them together. 7 by 3 is 21. Add them together. 7 by 21. 706, 80, 63. That's bad. Okay, well, 7 ain't working either. And this one had, okay, it looked like there were 2 real zeros. It looked like they were about there. But I tried those numbers, and it ain't those. So that means if I didn't see anything else, then there are no rational zeros. Okay, it was close. It really was. This one happens to have 2 zeros that are imaginary and 2 zeros that are radical, compound radicals. Okay, so it was a trap to try to hammer home for those of you who think you're just going to stare at a calculator screen and it's going to tell you the answer. Hint, hint, multiple choice final. It probably ain't that. Okay? Do it for real. Use the radical answers, or in this case, you have shown that it isn't one of those rational zeros. Okay? Ooh, wait. I want to do this one too because it does a thing. More. It does a thing. It does a thing. Why?
She had to pick out courses that weren't creative.
Oh, okay, that's legitimate. Otherwise, I would just generally avoid that.
I concur.
She's a nice kitty.
Okay, I've been writing mine out a little more formally, but I can just scribble the numbers off to the side and then write my list if you can keep things straight and not repeat yourself. Plus or minus all that stuff over 1. Oh, I missed a 3. And then all that stuff over 2. 1/2, not 1/3. 1/2, I don't want to write 2 halves. 3 halves, okay. I don't want to write 4 halves. I don't want to write 6 halves. I do want to write 9 halves. I don't want to write 12 halves, 18 halves, 36 halves. I already have all of those. But that's still a boatload of numbers to try. So again, I gaze into your crystal ball and you say, I feel really good about 2. Well, sometimes the crystal ball can lie. Sometimes it turns out they're just a quack. Okay? But I do feel good about 2.
I do feel
Alright, my crystal ball is done rubber banding.
All right, 2 worked. Yay. What else do we feel good about? Okay. This is where behavior comes in. What was it? 2, negative 4, 18. Clear. 2x to the 4th minus 4x to the 3rd plus 18x minus 36. Okay.
It's x to the 3rd, not to the 4th.
Oh, did I miss one?
And you have a 0 in here.
Oh, I completely. All right. See, I'm trying to do it from memory and it ain't working. 3, 2. So I don't need the 0. Yeah. You'd screw up too if you were up since 3:45. All right, 0, 1836. There, better. Okay. What else do we feel good about? 2 again?
I don't think. Not applicable.
No. Okay.
I'm trying to figure out.
You're like, it's this.
No.
So this would be
That we just connected
good window. I like it.
Okay. This is also where the rational root theorem comes in. Look at how big my rational possibilities were. Out to plus or minus 36. I should probably have a window that goes out to plus or minus 36. Really? That's it? Huh. All right. So what is this? 2x what? Well, that's x squared plus 9 is 0. So that's x is imaginary zeros. And it starts leading us into the back half of 2-4, which is, this is a rational root theorem. There's also things about positive and negative roots, Descartes' law of signs, there's the upper-lower bound theorem. There's all of this stuff, but when it really comes down to it, you have to understand that it's going to have 3 zeros. That's fundamental theorem of algebra. I found one of them. It's possible that the other 2 are imaginary or irrational because they always occur in pairs because of plus or minus when I square root them. So it turns out there was only the one rational 0. Okay. All right. Solving a polynomial. So this is just straight up solve it. They put it in context of a word problem, but it's just solve the polynomial. Boy, is this an old book. After the first half hour, the number of video games that were sold by a company on the release date can be modeled by this polynomial, where g of x is the number of games sold in hundreds, x is the number of hours after the release. How long did it take to sell 400 games? Who goes where? They said, how many something something 400? What do I do with that?
You put 4 in for x.
Look again, what are g of x and x? Number of games sold in hundreds. So I put a 4 there. So I got 4 is 2x cubed plus 4x squared minus 2x. Okay. Number of games sold in hundreds. Labeling matters. Then it's a polynomial. I solve polynomials by throwing everything to one side. So I'll say 2x cubed plus 4x squared minus 2x minus 4 is 0. And if I'm going to solve thingy, I should, okay, this one is factorable. Y'all remember doing factoring by grouping?
Yeah, you just boxes.
Okay. Divide everything by 2. Okay. X cubed plus 2x squared minus x minus 2. Because I can split this in half and say these two have a x squared in common. These have a negative 1 in common. They now have an x plus 2 in common. So if I take x plus 2 out, I have an x squared minus 1. Well, x squared minus 1 is a difference of squares. So that's x plus 2, x plus 1, x minus 1. X is negative 2, negative 1, 1. This is solving by factoring. There's other ways. The other way, like we've been doing, is once I'm at green, couldn't I 2, 4, negative 2, negative 4, and say all the factors of negative 4 over all the factors of 2 are my rationals? Start guessing and checking, maybe gaze into my crystal ball and say, I feel really good about trying a negative 2. Getting negative 4, 0. Oh, hey, look at that, I'm good. And say, I feel really good about trying a negative 1. Man, I should go to Deadwood this weekend. Like, numbers, they just come to me. and say, I feel really good about a 1. Score! Okay. Actually, that's why whenever we do casino night and game club, kids kind of don't like me playing Texas Hold'em with them. It might be illegal anywhere else, but if I'm not playing for money, that's true. It's not illegal. They just hate it when you break their system because you know math. Not like I've ever gotten kicked out of a place in Vegas. Not story time. I can either solve by factoring or I can synthetic division. Either way, I got my answers, my solutions, my zeros were x is plus or minus 1 and negative 2. But, go back to the question. What is x? It's in hours after release. I can't say negative 1 hours after release, negative 2 hours after release. That doesn't make sense. So how long did it take to sell the 4 games? 1 hour. Because I have to look at the reasonableness of my answer. Okay? Well, remember, this book was also written back in the day before pre-order. When I was in high school, we took turns skipping school for 2 weeks to hold our place in line in a tent in front of Best Buy so we could get a PlayStation 2.
Was it like a
PS5, but
Like the release of PlayStation 2. And we paid about $600 for it too.
was it like a group?
Yeah, it was like it was the 3 brothers, me, Nash, Nolan. Yeah, we all took like a day and skipped school to just camp. Anyway, do problem. Do problem. Do the problem! Yeah. Now you just pay and pre-order. In fact, GTA Vice City was the first game I ever remember they did a pre-order for PlayStation 2. Take a look at what means what. What is f of t? What is t? What number goes where? Solve. And it was only one weekend, and my wife got embarrassed, so she wouldn't let me gamble anymore. Yeah, being S.
Yeah, you just
You know, yeah, walking out with $800, but you're being escorted by 2 really big dudes wearing earpieces.
So you become a legend in my family. Yeah, that's like go down in history.
Yeah, I kind of grinned at her and said, "You want to go across the street?" But we didn't. We went and got ice cream instead.
$800 well spent.
how long ago was this?
Last week.
2005? Question mark?
Did you go back?
God, no. I hated Vegas. It's loud, it's crowded, it's hot.
Yeah,
You spend money, I know the odds.
yeah.
No.
You stay in a crash.
My brother lives there, and I don't know how he does it. I was there for Thanksgiving and almost died.
Plus, you get all the peddlers up in your personal space. Like,
There's a bunch of weird people in Vegas.
Yeah.
It's not very fun. You think it would be fun, and it's like, if you can't drink and you can't gamble, it's probably not a very fun
You
place.
are not 21.
It's not fun as a kid.
Really
Yeah,
fun.
it's not a fun place.
even then, it's not, because what do? I'm going to go there and make myself feel miserable and lose money.
That's why you go with friends and you watch them do that.
That's the fun of going to my adults.
So, I see 40, 4, and 20. Which numbers am I putting where?
Put
20 in for f of t, my height. Hey, do y'all remember seeing the vertical motion model? Negative 16 t squared plus v sub 0 t plus h sub 0. You've seen it since Algebra 1. Vertical motion model is basic gravity effect on a falling object. Your gravity effect is constant, initial velocity, initial height. So when they say at an initial speed of 40, look at what they threw in front of t. At an initial height of 4, that was your constant. Okay, so that's where the equation came from. So I'm going to plug 20 in for my f of t. And I'm going to put everything on one side. I'm going to say 16t squared minus 40t, and then plus 16, 0. I put everything on the left so that I'd have it positive. Either way, you're going to divide so you can clean this up a little bit. If I divide everything by 8, 2t squared minus 5t plus 2 is 0. Factors of 4 that add up to negative 5, perfectly feasible. But I could also just mental math my way to it, because I know 2t and t is the only way I'm going to get 2t squared. 2 and 1 are the only way I'm going to get 2. So it has to be 1 and 2 or 2 and 1 to end up with a negative 5 in the middle.
One is with the 2t.
1 then 2. It's a positive 2, but I ended up with a negative middle term. They both have to be negative. If you can mental math your way to that, go for it. If you can't, AC method says 2 times 2 is 4. Factors of 4 that add up to negative 5 are 2t squared minus 4t minus t plus 2. Cut it in half. Say these guys got a 2t in common, leaving a t minus 2. These guys got a negative 1 in common, leaving a t minus 2. Factor out the t minus 2, orange. Getting 2t minus 1 and t minus 2. Okay? So if you have to go for the full AC method, do it. If you can mental math it, do it. This is the 4th class you've done quadratics in. I'm going to trust that you can get there. So I've got answers of t is 1/2 and 2. What do those mean? So doesn't it make sense that you stick figure Steve thumps the ball, goes over the net, and it's 20 feet in the air at 2 different times? Okay, so time is 1/2 second and 2 seconds. So I can factor it. There was nothing wrong with having 16, negative 40, 16, and saying You know, I feel really lucky about a 2. Like that. And saying, I feel really good about 1/2. Okay? You can do it both ways. I'll tell you, you got to do it both ways in this class. Factoring is important enough that there is, throughout the class, there's going to periodically be a problem, maybe even a review problem thrown at the end of a quiz that just says, solve this by factoring completely. We got to know how to do it. Okay? So, upper and lower bound tests. Okay. I want to talk about it because it's dumb and I don't actually include it in the homework. Okay? But it's something that if you have done ACT recently, if you came to our ACT review a couple weeks ago, I don't want to be the guy that just never shows you the thing, and it happens to be one of those problems that's the difference between you getting the score or not, getting the scholarship or not. Okay? An upper and lower boundary test says that when I do synthetic division with a thing, it's written out in Mathese up here. But if I do synthetic division with C and I get all positives, that means C is a upper boundary for my zeros. It means there's no zeros past it. Everything, all the zeros are that way. Okay? If I do that same thing and I get alternating plus minus, plus minus, plus minus, plus minus. If I get specifically alternating, then it's a lower boundary. It means all of my zeros are that way. Where would that come in handy? What if I was guessing and checking 16 problems? What if I did my rational root theorem, I'm down to 16 numbers, and I say, I'm going to choose -3, and I get plus minus, plus minus, plus minus, plus minus? Okay, cool. That tells me don't choose -9, don't choose -18, don't choose -9/2, because those are all that way. This is a lower boundary. Pick numbers bigger. Okay? But since I don't have you guessing and checking the 16 different things, it's kind of redundant, right? But this is one of those theorems that helped us to narrow things down when the calculator's not working, when I don't have a graphing calculator on hand. When I plug the equation into the graphing calculator 5 different times and it keeps showing me the wrong thing. Okay, we had an issue yesterday. I still don't know what it was. I was Googling that crap after school too. So, upper and lower boundary test, that's all it is. I would say for you, if you want to know what the upper and lower boundaries are for a function, look at the friggin' screen. Say, I'm pretty sure the zeros are between -2 and 5. Ta-da. Okay? So, if you just want to write that, this, and then say, is lower boundary, and then C is upper boundary. If you just write that for this slide, I'm going to call it good. It's one of those random things that if it showed up on an ACT and I never showed you, I'd feel bad. Because if we got to play the game, play it well. Okay? Again, I got to double check the assignment. I know that tomorrow we will not have a daily quiz. We're going to come in and just try to finish off 2-4. I hope we can finish 2-4 tomorrow. but because it's a reduced class, I don't think we will. I just want to have every minute that we can. Okay? Y'all know that tomorrow, early release schedule, all the classes are about an hour. If you are released from Spartan time, you are allowed to leave at 11:24 tomorrow.